According to most people, regular expressions are hard to understand, hard to write, hard to modify or maintain, and also hard to test and debug. As I mentioned in the introduction in the previous video, lack of understanding often comes with blame. We tend to blame regular expressions for all these 5 problems. And you know, what we cannot attain, we tend to disdain. In order to figure out why this blaming exists, let's discover the journey of a regular developer, no pun intended. Let's see how a regular developer learns regexes. Many of us default to this journey of discovery when it comes to playing around with something we don't know well. With regular expressions, the task just seems too easy. We just have to create a short expression, right? Well, oftentimes this point of view is very wrong. Trial and error often takes more time than getting the pain handled and getting lack of knowledge cured. Yet most developers just default to trial and error or a regex generator over and over and over again. Therefore, my mission is to show that learning regexes is a lot easier than you thought, and it can be a lot of fun. And it's not only fun, it's also very beneficial because you don't have to write a 20-line long function, you just have to construct a small regex and your problem is solved. So we have already busted some myths. Trial and error is not enough. It's 100% this is not the way to go in regexes because regular expressions are very counterintuitive. Why are they counterintuitive? Because they are not declarative, they are imperative. There are many imperative elements in regexes. It's just like JavaScript. It has sequence. We have already seen sequence, by the way, in the examples in the first video when a character was followed by another character. We have selection, which is like an OR operator. You match either one character or another character. And we also have iteration in regexes, which is very much like a loop in a programming language. Match the character A as many times as you want to, or match the character B 5 to 7 times. This is iteration. This also works in regexes. Some other myths, well, we'll be able to learn regexes so we don't have to use a generator. We could play around with the generator while studying, but we don't have to do that afterwards. Avoiding regexes, regular expressions can indeed save you a lot of time. Don't do it. Let me repeat once more, regular expressions are imperative, they are not declarative. You have sequence, selection and iteration inside. You can influence the control flow of regexes. You can even pass arguments to a regex. You can reuse those arguments and return them. Capture a part of the match as well. And you can also optimize how your regular expression executes so that matching becomes faster. After discovering all these sticking points, let's see an example. In the last video we used the Chrome developer tools. This time we're gonna use a tool called regex101.com. This is a very interesting tool because you can write, match, test and execute your regular expressions in here. It supports the generic PCRE syntax, which comes with most programming languages except for Perl 6, and it includes JavaScript as well. And for now we're gonna use the JavaScript syntax specifically. Let's write our first regex, which is an A. It matches the character A. If we add the test string, which is a sequence of B and A characters, we can see that the regex matches the very first A. We can also set some flags, also known as Regex Modifiers. And if we set the global flag, you can see that all matches are highlighted in the test string. So this is how we can match each and every A. You remember the last video where we text searched the console, where the first result was highlighted in orange, all the other results were highlighted in green. This is what the global flag does. It highlights all the results. Or in JavaScript, it returns an object with all the matches. Let's add an other A to the regular expression. You can see that an other match is returned. Even though this is not the only match that could be found in a regular expression, generic matching just returns the very first result, which is in this case in the highlighted position. I have mentioned that there is sequence, selection and iteration in regexes. Let's see a selection. We can use the pipe, which is an OR operator inside regexes. So if we write A pipe B, this becomes match either the character A or the character B. In this case, the very first match is returned, which is the first character inside the regex, because the first character is indeed either an A or a B. We also have iteration in regexes. If you use the asterisk, for example by writing B asterisk, then what we write is match as many B characters as you can. As always, the regex returns the very first match, which is the first 3 characters of the string, so it returns BBB. Notice that matching with iterations is greedy. Therefore, even though the first result is returned, the matching consumes as many B's as possible. If you remember, it was not only sequence, selection and iteration that made regexes imperative. I also argued that you can influence the control flow of regular expressions. Let's see an example for that. Imagine that you have a regex last or list or lost or last. This matches one of those words. And we have a test string, the lost levels. If you change the flavor or the dialect to PCRE-PHP, there is an additional tool that appears on the left menu, which is the Regex Debugger. If we execute the Regex Debugger on this example, you can see that matching takes 26 steps altogether. You can reverse engineer the matching algorithm. It's not rocket science. Basically, it matches character by character, trying each branch of the alternative execution. A natural question to ask if we can do any better just with the knowledge that we already have with regular expressions. For instance, you can see that every word starts with L and every word ends with ST. So it's natural that we can just use alternative execution, or this OR operator, with just the second character. So why not write L parentheses A or I or O or U parentheses closing S and T. In regular expressions this is possible because parentheses are also available as a so-called meta-syntax character. These are like keywords or operators in programming languages. And if you execute this new expression, you can see that instead of 26 steps, we just have to execute 14 steps. We already saved almost half of the steps. And you can see why this happens. On step 6, we matched character L, and all we had to do in step 7, 8, 9, and 10 was to check whether the character after the L is either an A, I, O, or U. As soon as we found the O, we just had to match the S and the T, and we were done. Let's see if we can do even better, so we will save even more steps. This construct A or I or O or U can also be written as a character set. In regular expressions there are character sets which execute faster than alternative execution. The syntax is that we enumerate each and every character in brackets and we try to match them. The implementation in regex virtual machines work in a way that it constructs a bit mask and we just have to match that bit mask by trying to match the character. You don't have to know this syntax yet, we will learn it later. Thanks to the efficient bit mask implementation, you can see that the matching of the O character in step 7 was nothing else but just one operation, and we saved another 4 steps. So you can see that regular expressions are by far not declarative, and if you know what you're doing, then you can even optimize your regexes by influencing the control flow of the expression. This video concludes the introduction. Let's now learn the regex syntax